We're covering chapter 10, section 2, finding arcs. Your quiz on Thursday is covering 10.1 and 10.2. That's it. It's only 2 lessons. It's 10 questions. Majority of it is from 10.1, but you're going to have some questions from 10.2. All right, looking at this, we're covering arcs. This is central angle. This just means your vertex is meeting at the center of the circle. So when you're looking at this, your vertex is the point where the 2 lines meet, and it's meeting at the center of the circle. All right, things that you need to know for this. If it's starting from the center to the side, this is going to be really messy. If I'm starting from the center to the side, what is this side called? What is this line called right here? Good, this is called my radius. You guys are going to have vocabulary on your quiz. Okay, that's my radius. The angle is specifically talking about this angle right here, ABC. So when you're looking at it, central angle is where your vertex meets at the center of the circle. All right, arcs. There are 3 main arcs. You have minor, semi, major. Please understand what these are. An arc is broken into parts of a circle. Keep in mind your arc is considered part of the circumference. Your arc is talking about the arcs, the circular part of the circle. So when you're looking at this, you have what's called a minor arc, which is less than half of the circle. You have your semicircle, which is half the circle. And how many degrees is half of a circle? 180. Good. If a circle is 360, half of it is 180 degrees. Please make sure you understand that. Write it down somewhere. And then you also have a major arc, which is the arc greater than half the circle. So it's 181 to 360. Okay, 180 larger than 180 and stops at 360. That's your major arc. Okay, it's the majority part of it. All right, so looking at these arcs, they want us to name it. Okay, if CD is the diameter, what does the diameter mean? A line that doesn't go through it, but it goes from one point of the circle to the other, and it's that straight line. So this line right here is separating my circle into 180 and 180. Okay, that's the diameter. Arc, it says arc AC is a blank type of arc. I want you guys to also know that arcs can be written with a little arc on top. When you are writing arc, it has to have that curve. So we have been using a straight line above it. Using arcs, it has to be a curved line. If you're giving me arc AC and you're writing it like this is going to be wrong. Okay, so your arcs have to have that curved line above it. So arc AC is right here. I'm doing it in red as well as the arc symbol. Is this a major, minor, or semicircle? Minor. Good, this is going to be a minor arc. It's less than 180. So now looking at the next one. DAC. So I'm writing as arc, DAC. I'm just drawing my arc symbol. And when you're writing it this way, remember, arcs are the perimeter of the circle, so I can't go straight across to C, okay, or I can't go across to A. It has to be, I'm following the arc. So here's D, it's DAC. I'm going from D to A to C. What kind of arc is that? That's my semicircle. And then the last one, arc ADC. So again, following it, A. DC, what would that be considered? My major arc, it's more than 180. So just making sure we have all those there. I have my minor arc, my semicircle, my major arc. And then they also gave me my diameter. All right, measures of an arc. Now we're trying to find the measurements of an arc. The measure of an arc is equal to the measure of the central angle. Super important that you know. So your angle measure, the measure of your arc is equal to the angle measure. So let's go ahead and answer these. Looking at it, this angle right here is 50 degrees. What's the measure of arc AC? 50 degrees as well. Okay, so it's going to be the same. Now, before, last question we had, this is my diameter. What does this entire straight line equal? 180. Okay, I'm glad that we all know that. Now, looking at it next, they're asking me for CAD. What's the measure of arc CAD? 180. And now, lastly, they're asking for the measure of arc ACD. How would I figure that out? Good. 180 plus 50. And what's 180 plus 50? 230 degrees. Okay, so your angle measures are the same as your arc measures. So please do not forget that. You guys will definitely get questions like this on your quiz on Thursday. All right, adjacent arcs. Arcs that have exactly 1 point in common. We should already know what adjacent means. Does anybody remember what that word means? Good. Adjacent, I'm just going to write it, means next to. Okay, so there are adjacent angles, which we should be able to know that. We should be able to figure that out. Looking here are adjacent arcs. So let's just state what's adjacent. TQ, arc TQ is adjacent to what? Okay, good, I have QR. Okay, so they're next to each other. Looking at it, they have exactly 1 point in common, which is Q. Let's go ahead and find what is the measure of angle SR. Arc, or what's the measure of arc SR? Not 120. They're not completely vertical angles. Yeah. It's not going to be 80. It's not 260. Yeah. It's going to be 100. So looking at it, what does a total circle equal? 360. So you could either do 360 minus 120 minus 80 minus 60. Or if you're looking at it, you can figure out where is a straight line here. Right here is a straight line. So I have 180 over here. I also have to have 180 on this side. If they're already giving me 80 out of my 180 degrees, my leftover is going to be 100 degrees. Yeah.
Is there no marker? Like, we don't have to prove that this goes right through the middle? Because, you know, like with, like, triangles and shapes, like, you can't just prove that a degree is 90 degrees unless it has a symbol.
Mm-hmm.
So for this, it's different. Like, if it looks straight, then you know it's 180.
No. You don't know it's 180. But giving me, for this one, because if they're giving me 120 and 60, 120 plus 60 is 180. So I know that that's going to be a straight line.
I know, like for this one too, like how would we like prove that?
I think for the question before that, they told you that it was the diameter. So they were just using I guess, the same circle. I would probably clarify it in the directions, if anything. Or I would let you know. All right, so for this one, it's just a postulate which you guys have seen over and over again. Something addition postulate. Instead of doing angle, instead of doing segment, now we're doing arc. That basically just means if you are adding arc AB plus arc BC, it's just going to give you the entire measurement for arc CABC. So it's just saying if you're adding them, it's giving you the entire arc for the entire measurement of the arc. All right, for this one, congruent circles theorem, the only time your circles can be congruent is if and only if you have the same radius. And we should know your radius is from the center to the side of the circle. It has to be the same. So if they're both 4 units, or 4 meters, or 4 inches, whatever units you have, it's the same circle. They're going to be congruent circles. All right, congruent arcs. 2 arcs are congruent arcs if and only if they have the same measure and they are arcs of the same circle or of congruent circles. All right, congruent central angles theorem. In the same circle or in congruent circles, two major arcs are congruent if and only if their corresponding central angles are congruent. So giving you an example here, if both of these angles were 50 degrees, remember your angles are the same as your arcs, then these are also going to be 50 degrees. So this is just an example. It's not always going to be 50, but I'm just showing you your central angles are going to be the same as your arc measurements, and they'll be congruent if they have the congruent symbols. All right, similar circles theorem. A circle, all circles are similar. That doesn't necessarily mean they're the same, it just means they're similar. Two arcs are similar arcs if and only if they have the same measure. So if and only if they have the same measure. All right, for this example, we need to name two minor arcs, two major arcs, two semicircles, an acute central angle, and two congruent arcs. I'll do the first one for you, then you guys are going to do the rest. So it says two minor arcs. Can someone give me one? Yeah?
R and A.
Okay, good. So I am writing it as RA with an arc on top. Or you could write this as AR. It's the same thing. And then who could give me another one?
RC.
Good. RC. Arc RC. Or you can write it as arc CR. So go ahead and do the rest by yourself. And then we're going to go over them. So looking at the two major arcs, I'm going to go over these. So go ahead and check our work. Major arcs. Who could give me one major arc? One major arc, just one. Okay, I'm going to have RAC. Okay, that's telling me I'm going from R to A to C, so it's going this way, which this is a major arc. Who could give me another one? Okay, RCA, arc RCA, so I'm going to put my arc symbol. So here's R, C, then going to A. This is another one. Anybody else have more? There's a lot of other ones. Yeah? Okay, we have D, CA. This is an arc. All right, DAC, D or DCA. Good, that's a major arc. Okay, point D is right here. Who can give me another one? William, you were going to say something? CDR. Okay, CDR. Good. Anybody else have something else that they want to just double check? No? Okay, those are fine. Now, semicircles. Yes, some of you may say, oh, if point D is here, then this makes a straight line. I don't know that. So I am personally going to go off the line that's provided. So looking at it, I'm going to say AC, this is a straight line. Okay, for these you could kind of sometimes see, but I'm going to take that one as a straight line. So for semicircles, you cannot just write arc CA. That's not a semicircle. You'd have to write it using 3. Who can tell me how they would write it? Yes. Okay, I have arc CRA. Good, that's one. And who could give me another one?
Arc CDA.
Arc CDA. If you put ARC, that also works. And if you put ADC, that also works. Okay, and then an acute central angle. Who could give me one acute central angle? There is only one. ROA. It has to talk about the specific angle. So if you're just giving me RA, you're not giving me an angle. Remember, naming angles, it has to be 3 letters. So how you're writing this is angle. Okay, so you have to have that angle symbol, not an arc symbol. They're asking for an angle. Angle, ROA. Or if you wrote angle AOR, those two are the same. You could write either one. But you have to have, most important thing for this one is that angle symbol. Do not write an arc symbol. You would get it wrong. All right, and then the next question, the last question is two congruent arcs. The only two congruent arcs that I know are going to be congruent are my semicircles. Okay, so naming that, I'm going to have two. We said CRA and CDA. Those are my two semicircles. Questions on this? You guys will have to label something like this on your test. Example 2, give the measures of each angle or arc. So again, there is a difference between angle and arc, but most of the time the angles are going to be the same. The measures are going to be the same. So looking at it, I have WX. So looking at WX, they're asking specifically for the arc. What is the measure of that arc? How would I find that? Okay, 180 minus what? 50 minus 30, which would be 80. So what's 180 minus 80? I would have 100 left over. So this right here is 100 degrees. Now they're asking me for the measure of angle, WOT. What would that measure of the angle be? Good, if my arc is 50, my angle is also going to be 50 degrees. And then what about X, arc? X, Y, T. What would that measure be? Good, so I'm taking 150. Not 150. What would I be adding? William? 180 plus 30. What would I get? Good. 210 would be my angle measure, my arc measure. And then the last one, angle YOT. What would that be? That would be 180 degrees. Any questions on these? Not too hard. You guys will, again, have a question like that on your test.